Hey everyone, this is going to be a video talking about calories. So calories is simply just a measurement of energy. So when we're communicating how many calories in our food, all we're doing is saying how much energy is in that food. There's actually a lot of ways to measure energy, and calories is just one of them. In fact, some other units of energy are joules and kilojoules and calories and kilocalories. We just so happen to use calories in terms of food. One thing that you're going to need to be comfortable doing is converting between all these different units of energy. Some of these units of energy are more appropriate in certain circumstances than others, so we need to be able to go between them. And right here are your conversions in order to help you do that. So I would write these down somewhere or just have them readily available for you to use here in the future. So 1,000 joules is in a kilojoule. That's kind of like how 1,000 meters is in a kilometer or 1,000 grams is in a kilogram. You've got that kilo prefix. And then the same thing as 1,000 calories being in a kilocalorie. The main one here is this 1 calorie is equal to 4.18 joules. So that's going from two completely different measurement units. So one thing you need to be comfortable doing, like I mentioned, is converting between these. So we'll go ahead and we'll try a practice problem here. So 2.5 kilojoules is how many kilocalories? So remember how we do this is you take that number, whatever number I give you, and you're going to put it over 1. So 2.5 kilojoules. You know what, we're going to do this. Boom, tinier, please. Okay, 2.5 kilojoules over 1. And then you're going to go ahead and set up your next step. If you just did 2.5 kilojoules, remember, then you're going to take that unit and you're going to put that on the bottom. So I'm going to go ahead and put kilojoules then on the bottom. And it looks like my goal here is kilocalories. So since I've got kilojoules, I'm going to go ahead and look over here. And it looks like I can convert kilojoules to joules. So that's what I'm going to go ahead and put on the top is kilojoules to joules. I don't want joules though, so I'm going to keep going. I'm going to take joules and I'm going to throw it on the bottom. That way it cancels out. And then I'm going to go ahead and look back over here and see what I can convert joules to. And it looks like I can convert joules to calories. So I'm going to put calories on the top. But it specifically wanted kcals. So I'm going to do one more step and I'm going to go calories to kcals. And that's going to be my basic setup. After you have your basic setup, then you need to plug in your numbers. So looking at my little chart over to the side here, it looks like there's 1,000 joules in 1 kilojoule. There's 4.18 joules in 1 calorie, and there's 1,000 calories in 1 kilocalorie. So I'm just using these values from over here to plug in over here. So if I go ahead and type all that in, multiplying across the top and bottom, 2.5 times 1,000 divided by 4.18 divided by 1,000, sig figs, I'm getting 0.60 kilocalories for my final answer. So that's one thing that you should be able to do is converting between these different units. And here's one thing that is, I think, very interesting is, so you know how we always say, you know, like, oh, here, we'll come back up here. So 1 serving of Doritos is 150 calories. Well, that's actually really misleading because it's actually 150 kilocalories. That's what actually all of our food is measured in is kilocalories rather than just calories. But for whatever reason, in our society, we have dropped the kilo part and we just say calories, even though it's actually measuring kilocalories. So for example, if we go ahead and compare, these are 2 cans of Coke, one from the United Kingdom and one from the United States. If you look at the UK Coke, notice how they've got energy and they've got kilojoules and kilocalories. So they actually keep the kilocalorie, where in the United States, we just say calories when that's actually a lie and it's kcals. So like I said, I'm not sure why, but for whatever reason in our culture, we've eliminated the kilo, the kcal part of it, and we just say calories instead. Before you get up in arms over like, oh my gosh, United States Coke is so much more calories. The nutritional information is per 100 milliliters over here, and this is a 330 milliliter can. So all that information is just for 100 mils of the can. So if you take all those values and multiply them by 3.3, then it's basically just a wash. So now that we know what calories are, basically just a measurement of the amount of energy within a food, now we're going to talk about how you can figure out how many calories are in a food. More specifically, kilocalories that are in a food. One way is to do some math. So essentially what we know is that 1 gram of carbs or protein is equivalent to 4 kilocalories and 1 gram of fat is equivalent to 9. So basically, if you are creating a new food and you know that you put 2 grams of carbs and 2 grams of protein and 2 grams of fat, you can essentially do the math, given 1 gram of carb and protein is 4 and 1 gram of fat is 9, add them up and boom, then you know how many kilocalories are within a food. So that is one way to do it. So for example, with that information, we can basically do a bunch of different conversions. So here, let's do the second one first, actually, and then we'll come back up to the first one. So looking at this one here, how much energy in kilocalories comes from the total carbohydrates? So we are given all the information here. Okay, so they've already added up all these values to get to the 150 kilocalories. But what if we were curious just about the carbs? So the total carbohydrates is 17 grams. So I've got 17 grams of carbs. I'm going to take that, I'm going to put it over 1. And then what I'm going to do is I'm going to convert these grams of carbs, if I can write, grams of carbs to kcals, because I'm curious how many kcals are coming from the carbs specifically. And in order to do this, I'm going to use the information from this slide. 1 gram of carbs is equal to 4 kcals. So coming down here, 1 gram of carbs is equal to 4 kcals. So 17 times 4 is a number, 68 kcals. So 68 kilocalories of the Doritos are specifically coming from carbohydrates. We could also do the same thing for the protein here. So if there are 2 grams of the protein, and we come up here, it looks like 1 gram of protein is equivalent to 4 kilocalories. So 1 gram of protein is equal to 4 kilocalories. 2 times 4 is 8 kilocalories. All right. And why don't we just finish it off, okay? So the last one, we did carbs, we did protein, now we just have to do fat. So the total fat here is 8. So if we go ahead and do my 8 grams of fat, put that over 1. 1 gram of fat, going up to my earlier calculations, 1 gram of fat is equal to 9 kilocalories. So 1 gram of fat is going to provide more energy than a gram of carbs or a gram of protein. So if we go ahead and come back down here, 1 gram of fat, yes, isn't that interesting? 1 gram of fat is equal to 9 kilocalories. So 8 times 9 is a number, 72. But let's follow sig figs, only one sig fig, so 72 would go to 70. Bud, did I tell you I got a dog? I got a dog. Yeah. All right, so, yes, okay, pausing. Anyways, so if we go ahead and add all these guys up, you get 146 kcals. If we bring that to 2 sig figs, hang on, because if we line these all up to the hundredths place, right, because this one is in the hundredths place, but it's only 1 sig fig, so if we line this up to the hundredths place, you get 150, and boom, that's where the 150 is coming from. Also, the calories from fat, 70, we've got down there as well. So basically, if you know what you're putting into the food, and then you keep in mind these conversions here, that is one of the ways you can figure out how many kilocalories are located within the food. Why don't you go ahead and quick try these 2 examples on this slide and then check back in when you're ready. So if you want to quick check your work from these guys, here you go. Basically, just make sure that you also have these conversions written down well and you can use these. So this is just for fun. This is nothing that you'd be quizzed or tested on. But you might know that the average person needs to consume 2,000 calories in a day. Now we know that's kilocalories in a day, right? But obviously people are vastly different. There are a bajillion factors that go into your health and your body and your image and what your energy and intake needs should be. This is one fairly simplified way to do it, but if you're curious just to kind of have a ballpark range, this is one way you can calculate that. This takes into account your weight, your height, your age, your sex, and then also your activity level. This is just going to give you a very ballpark range. Like I said, your health and what you consume and what you need to consume is going to completely vary on person to person. You are a lot more complicated than just these 5 factors, so I don't want to simplify that. But you might be intrigued to see where you fall around that 2,000 number. So for example, I fall usually around like the 1,900 number, so just a little bit less than the average person. Mainly because I'm sedentary. I'm working on it. So I'm not very active, so I shouldn't consume a lot of food because I'm not doing a lot of work to get rid of it. Where if you are incredibly active, you need to consume more calories and more energy in order to sustain that workout. So just something to keep in mind. So the last way you can figure out how many calories are in a food, kilocalories, are in a food, is by performing a calorimetry test, which is an energy measurement test. And there is an equation that goes along with this. Q is equal to MC delta T. Essentially, if you can plug in your values here, you can solve how much energy is in a particular food or item or anything, really. So looking at the different variables here, the Q on here is energy, and I want you to be very mindful that this is energy in joules. So you know all those different energy variables we talked about? This particular equation, the energy is always in joules rather than calories or kilocalories. The M in the equation stands for mass. The C in the equation stands for specific heat. That's a new thing I'll talk more about here in a bit. And then delta T stands for the change in temperature. This triangle sign here is a symbol for delta, and in the chemistry science world, delta stands for change. So this is how much the temperature would change. So like I mentioned, that letter C in the equation stands for specific heat. The definition of specific heat is the amount of energy required to heat 1 gram of a substance 1 degree Celsius. Basically what that means is different substances will change temperature based on the amount of energy they are given. So for example, let's say it's a hot summer day. Okay, we're almost there. It's a hot summer day and you go to the beach and your car has been sitting out in the sun. And let's say you've got like a cloth interior. You slide in after the beach and you grab the belt buckle, and as you're buckling yourself in, you hit yourself with the middle buckle and it burns. But you're sitting in your cloth seat just fine. That is because of specific heat. So the cloth interior and the seatbelt, the metal buckle, were exposed to the same amount of energy. They were both sitting in the sun, but one had a very high temperature change. The belt buckle is super hot, and the cloth interior had a low temperature change. It's still not as hot. So that's specific heat. So for example, I've got 2 values right here, water and iron. So like if you're boiling a pot of water, for example, the metal pot is going to get hot right away, but it takes a really long time for the water to get hot. That is because of these different specific heats. And the specific heat here is representing the letter C in our equation. And again, our equation is Q is equal to MC delta T. So let's try an example here. If a 2.65 gram sample of water was heated from 25 degrees Celsius to 37 degrees Celsius, how much energy was used to heat the water? So I'm solving for how much energy. I'm solving for Q. So Q is equal to M is the mass. So I said that was 2.65 grams. C is the specific heat. And since this is water, I'm going to use the specific heat value of water, which is 4.18. And then delta T is the change in temperature. So notice I've got 2 temperature values here. So this is going to be how much it changed. So it ended at 37, but it was 25. So if it's 37, but it was 25, the change is going to be 12. So 12 degrees Celsius is going to be the value I plug in for there. So always how much it's going to change. So I type this in, 2.65 times 4.18 times 12, 2 sig figs. I am getting Q is equal to 130. And remember, the value is always joules for our Q, for Q is equal to MC delta T.